Welcome to Pre-Calculus. Today we will investigate converting angle measure between degrees and radians. We'll take a look at four examples. Our first two examples are giving us degree measures, and we want to convert it into radians. So here on example one, I've got 20 degrees, and what I need to think is how I can make that conversion. So if I consider the coordinate plane and just think about marking some angle measures here, I'm really just going to think about a half rotation. That's going to give me in degrees 180 degrees. Now, if I were thinking of that same rotation, half rotation there in terms of radians, the equivalent measure to 180 degrees would be pi radians. So to make a conversion, I need to multiply by that conversion factor. And I'm going to use these two parts because I know that 180 degrees is equivalent to pi. Now, I want to cancel the degree unit there. So as I set this up, I'm going to multiply by the ratio between these two versions of a half rotation. And I need the degree to go below so that the unit will cancel. So I'll put 180 degrees below, and I'll put pi above. When I think about the value of this fraction, it's really pi divided by 180. If I think about what it's doing on this coordinate plane, it's essentially something divided by itself. The value of this is 1. So it's not like I'm multiplying to change my 20 degrees. It's really just a conversion factor. So I'm going to multiply 20 degrees by pi over 180. I see that the degree unit cancels since it's both above and below. And then I want to make some reductions if possible. I see that I can divide 20 out of 20. That'll leave me 1. And 180 divided by 20 is going to leave 9. So the equivalent radian measure for 20 degrees is going to be given by 1 times pi, which is pi, over 9. So 20 degrees is equivalent to pi over 9. I do want to sketch that angle just to visualize what we have described in two ways, 20 degrees, pi over 9. So 20 degrees, if I were to divide 90 into 3, that's groups of 30. And so then if I divide one of those into 3 parts, my 20 degrees is given by a sketch like so. So I can mark that as 20 degrees or pi over 9 radians. Our next example is negative degree measure. So this is negative 140 degrees. So just like we did in the previous one, I want to convert it. But let's sketch this one so we can visualize where this 140 degrees is on the coordinate plane. So I'll start in the standard measure. Remember, negative direction is clockwise. So from the positive x-axis, 140, negative 140, I'm sorry, it's going to be negative 90 degrees. And then I need to go 50 more degrees. So just like we did in the previous example, I'll divide that 90 into 3. And since I need to go 50, I'm going to divide it into tens. I just need to go 5 of those. So 1, 2, 3, 4, 5. 140 degrees would have a sketch like so. And I need to make sure that I mark that as negative 140 since it is in the clockwise direction. Well, let's find the radian equivalent to negative 140. So I just need to multiply by the same conversion factor. So I know it's going to be a cancellation of the degrees. So I'm going to put the 180 degrees below, pi above. Immediately, degrees will cancel. And then I need to find reductions if possible. So I see that both 140 and 180 are also divisible by 20. So 140 divided by 20 is going to give us 7. 180 divided by 20 is going to give us 9. And 7 and 9 are prime to each other. So I can multiply across now. This is going to be negative 7 times pi over 9, and that's fully reduced, negative 7 pi over 9. So I can label my sketch both in degrees and in radians. So our first two examples, we're looking at converting from degrees to radians. Our last two examples are going to do the opposite. I'm going to have a radian measure, and then I want to convert that into degrees. So just like we did previously, I want to multiply by the conversion factor, but I don't want to multiply by the same one, pi over 180, because here I want to cancel the pi. So where I'm going to place pi is with respect to where it will cancel. So if in the numerator for the radian, in the conversion factor, I'm going to place pi in the denominator, and the equivalent angle measure 180 degrees in the numerator. So once I've got that set up, I'm going to make the cancellation. Pi divided by pi is 1. And then I'm going to try to reduce some of these numbers. I see I got 12 in the lower left, 180 in the upper right. And I see that 12 times 15 is going to give me 180 degrees, or 180. So I can divide out 12. It's going to leave 1 in the denominator, 15 up here in the numerator. So all I got to do now is multiply across. 5 times 15 is going to give me 75. And I see that I've got this unit. That unit has not canceled. So it's going to be 75 degrees. And in my denominator, it's 1 times 1, which is really not anything to record there. It's 75 degrees. So again, I'm going to come back here. Let's sketch this one. So a lot of times it's easier to sketch from the degrees since the radian is very fractional. So there's a few radians that we can easily sketch, but I'm going to work from the degree 75 for the sketch. So I know that this full quarter rotation is going to be 90. So I'm going to divide that into 3. Divide that into 3 parts. So each of those increments is going to have the value of 30. If I split them into 2s, each of those is 15. So 15, 30, 45, 60. One more would give me 75. So my sketch here for 75 degrees, it's in quadrant 1. I can mark it 75 degrees, or the original 5 pi over 12 radians. Our final example is also a conversion from radians into degrees, again looking at a negative angle measure. So this is negative 23 pi over 18. I'll start again by multiplying times my conversion factor. And remember, when I'm going from radian to degrees, I want to cancel the pi. So if my pi is in the numerator, I'm going to place it in the conversion factor and denominator and 180 degrees above. So then I've got cancellation, pi divided by pi is 1. And then I've got a convenient cancellation between 18 and 180. 18 divided by 18 is 1. 180 divided by 18 is 10. So if I multiply directly across, it's going to give me negative 23 times 10, or negative 230 degrees. Again, my denominators are just 1 times 1, so I won't record that. I'll just box negative 230 degrees. To sketch this one again, I'm going to work from the degrees. Remember, counterclockwise starts at standard position, the positive x-axis, and goes clockwise. So to catch 230 degrees, I'm going to make a half rotation, that's 180. And then the difference between 180 and 230 is 50. So I need 50 more degrees. So I'll mark this quadrant 2, which is 90 degrees, into 3 parts. So each of those is 30. I'll divide those further into tens. And that gives me a way to find 1, 2, 3, 4, 5, 50 more degrees in the negative direction. And that is my negative 230 degrees. So I'll mark it in degrees and also in radians. So negative 230 degrees or negative 23 pi over 18 radians. Thank you for joining for this investigation of converting angle measures between degrees and radians. See you soon.